Okay, let's go ahead and get started. I got a couple after 2 o'clock. That's not the slide I want to have. I'm gonna have that slide. Okay, so thank you all for attending. Again, this is the second session of NextGen Geospatial. I'm your instructor, Jeffrey Gillen. I work for Cybers and the Data Science Institute here on the campus of the University of Arizona. So I am live here at the Weaver Science and Engineering Library on the U of A campus in Tucson. And so today's session is all about Google Earth Engine. So we have 1 hour together. And so this is going to be pretty high level. This is just kind of what is the tool, why it's powerful, how you get access to it. And I'll do some like kind of basic tutorial, show you how to input data, how do you make an app, just kind of like the 101 on Google Earth Engine. It's a deep platform. There's a lot to learn. So this is just kind of an exposure, if you've never played with Earth Engine before. So I will stop let's get out of that. Okay, can everyone still see my screen? Yep, looks like that's true. Okay, so up on the screen is the home page for the course, for the workshop series, NextGen Geospatial. We have it up here on GitHub. Michaela, can you throw that in the chat as well when you get a chance so people know how to get to that address? This material is asynchronous too, if you want to just access it on your own time and look at some stuff. That's why we built it there. And Michele is my co-host and colleague, Michele Kosi. He's going to be joining us today and doing some logistics. When I talk, he mans the chat and other logistics stuff. And then when he talks in an hour, I will do the opposite. I'll help him. So thank you, Michele. Okay, so here's our homepage. You guys know all about the workshop by now. This is intended to be kind of like a discrete 1 hour, learn about a tool. We're going to do something different every week. Go down to our schedule here. And so it is September 10th, and we're going to talk about Google Earth Engine. So I'll go ahead and click on that specific course content. And as I'm going through this, feel free to stop me and ask me a question, or, we do want to keep it kind of high level, specifics on like how to use that Python and stuff like that this is probably not the exact time or place, but we'll be happy to go in as deep as you want afterwards, so please reach out to us, contact me, and we can talk details. So what is Google Earth Engine? Earth Engine, brought to you by Google. You might have heard of them. It is a really kind of amazing cloud-based platform for geospatial data analysis. It really kind of excels, I think, in raster data. So think about satellite imagery or aerial photography or drone or anything that can be put on a map. Geographic coordinates could be analyzed in a very powerful way in Google Earth Engine. So it is basically free for everyone to use. If you have a Google account, which all of you do, I'm sure, then you can get started going. If you need to do something much higher level, like real big production, I think you're gonna have to eventually pay Google for those services. So Earth Engine is on Google's cloud. And it is what I call a groundbreaking platform. They really kind of invented the category of doing remote sensing away from your desktop and accessible just through your web browser. And so they really kind of invented geospatial cloud computing. And you can do things on a small scale, or you can do things on a gigantic planetary scale. The data is there, the compute is there, the analysis tools are there. So it's just a really great environment for people doing all kinds of things. So let's start with getting access to Earth Engine. Some stuff to know about that. Let me zoom in a little bit. Yeah, make my screen a little bit bigger. Okay, so the most important thing to know about access to Earth Engine is you use a Google account, but it's not going to work using a university Google account. So your arizona.edu is not likely to work. So please use a Gmail account. If you don't have one, you can create a free Gmail account. The reason why the university, it will not work with your university email is that you have to set up a Google Cloud project. And I believe the IT at the university has disabled that. And so they just check some kind of radio button. And so you're not going to be able to access Earth Engine through your university account. That's okay. Get a free Gmail account and then you're off and running. So in this paragraph here is, there's actually a link, a blog by my colleague Sam Apria Roy, who goes into a little bit more detail about how to get things set up. But this link here, code.earthengine.google.com/register, should send you in the right direction. So I'll just go ahead and launch Earth Engine. And I do it in my Google, like my personal Google profile. And so I have to usually open up a different tab and not be in the university's Google environment. So it is code.earthengine.google.com. So I've already set up my account. And so it's just going to go directly into this code editor. Okay, and so this is what we call the integrated development environment for Earth Engine. If you guys are used to using ArcGIS or Erdas Imagine or Envy or a lot of those other tools that are very kind of graphical based, pointing and clicking, going down menus, stuff like that, Earth Engine is not really like that. It's really script based. So it's closer to like a RStudio or something like that than it is to like ArcGIS. So there are not a lot of prepackaged buttons that you click on. Everything you do is done through a script. In this case, it's JavaScript. And so yes, there is a little bit of a learning curve in terms of understanding how to write the JavaScript or in what order and that kind of stuff. We're probably not going to get a great idea of how to do that today. That's more of a kind of a personal journey, but we can show you kind of basics, get you going in the right direction. And so yeah, so here's my Earth Engine interface. I have a map, and this is where all my geospatial data is going to be displayed. Middle tab here is where we actually write our scripts, write our JavaScript to do things, to import data, to do analysis, any kind of action that's going to be written in a script right here. Let's just go ahead and let's see what other things I need to cover. Yeah, so this is a JavaScript code editor or an integrated development environment. Google Earth Engine has a lot of great help already. So I do not want to reproduce what Earth Engine's already made in terms of all their help documentation. In my little tutorial here on my course website, you can find links that will go to all of those kind of definitive pages in terms of like how you use code editor, how you just basically do everything. They have pretty good help. Okay. Before we actually get into tutorials and doing things for real, a few things to know. Google Earth Engine has a large data catalog, and we're going to show some of that here in a little bit. But you can also input your own data. So that's kind of the power. Like if you're using Landsat or MODIS or any kind of, name it satellite imagery, it's already in Earth Engine. You can just easily call it up with a little JavaScript line. Very easy to do. If you want to analyze your own data, I believe for a free account, you can get a maximum of 250 gigabytes of space. And so I maxed that out pretty quick. So I do a lot of drone stuff. And so about 4 years ago, I did a big project in Earth Engine where I uploaded, I don't know how much, 0.5 terabyte of drone imagery. And yes, it did take a while to get all of that over the wire into Earth Engine's Google Cloud. But once it's all in there, it's very powerful. I can analyze, a terabyte data with, click of a button and a few moments of processing. So you really do have access to a lot of compute from Google Cloud. So personal storage, you can bring your own data to the fun. Collaboration. Okay, what makes Earth Engine also unique is that you can collaborate. And so as I'm doing scripting, I can just create a link here and I can just send that link to my buddy. He can click on it and open my code in his instance. And so what else? You can also share data sets. So if I upload a bunch of drone imagery, I can easily give permissions to anyone to read, write, or own that data that I put in. And so when we do things on the cloud, everyone can kind of tap in. Think of it kind of like Google Docs or HackMD or something. If we're all working on the cloud, we can all kind of work in the same space and collaborate. So that's a very nice feature with Earth Engine. Collaboration. Okay, data catalogs. There is a lot of data to be had in Earth Engine. So there's the official Earth Engine catalog, and they claim to have 70 petabytes of data, 800 plus curated geospatial data sets, including like all of the timelines and time series of satellite images. So Landsat, MODIS. I think there's some planet imagery, a lot of the sensors from the European Space Agency, just lots of stuff. And so let's look at some of the data from the Earth Engine catalog. So this is the Earth Engine data catalog homepage. And so they've done a really good job of making this pretty intuitive and pretty easy to kind of click through and see what you want. So this is where you're going to find all your data. And if we just scroll down, they're just highlighting some data that you can bring in: surface temperature, all kinds of climate models, atmosphere, weather, imagery. You can do animations. You can even get high-res imagery like NAPE and other kind of aerial photography. Lots of different land cover. Let's see, cropland. Let's go click on cropland. What might be interesting: USDA NASS cropland data layers. I'm not really familiar with that data layer, but let's just click on it anyway. Okay, so this is from the USDA, National Agricultural Statistics Service. Gives you a little bit of details about what this data is, who it came from. And then the most important part is this is the code snippet to bring that data into your computing environment. And so I can do this little copy here. Go back to my Earth Engine. That's it. I would hit run. So I'm just going to run that code, and then it pops up. So you can do this for all of the data sets that Earth Engine has. Just tons of data, and they give you a little snippet, code snippet, and this is in JavaScript to be able to display that. What else? Yeah, and so I can zoom in. I don't think there's a key, like a legend explaining what the different colors mean. There might be, so here's the inspector tool, which is like a query tool. You can click on it and it'll tell you information. It's cropland 121. I don't know what that means. Somewhere back in the information on the data catalog, it probably tells you what these numbers or what classes they represent. But what's that? Yeah, it could be like back in here. Is that what you mean? Yeah, the bands. Yeah, okay. Yeah, there you go. All right, it's all there. Okay, wow. So yes, they have classified the land based on crop type, which is pretty neat. I wonder if they do that every year, because it would change, right, from year to year. Wow, watermelons. Okay, you guys got the point. So that is the official Earth Engine data catalog. All kinds of data, 70 petabytes of data that you can just play with. You can bring it in, you can analyze it, and we'll get to the analysis in a minute. So that's the official catalog, and then there's the awesome catalog. And so the awesome catalog was put together by our colleague Sam Roy, and this has kind of been a labor of love for him. Earth Engine has a big user community. And so there's a lot of people around the world who use it, who have input data sets, but there's no way for anyone to find a contributed data set. And so Sam Roy took on that initiative to connect all of it. And so on a GitHub repository, he has additionally made a gigantic catalog that is not in the official catalog. So there are two very large catalogs of data. let's check out his catalog here. There we go. There's Sam. Did a great job of making this catalog. And so I can go to data catalog here, and gosh, then I've got kind of whatever I want. Hydrology. Surface area of rivers and lakes. Okay, so it gives you a little description about what it is, who contributed the data. And then a little code snippet for how to bring it in. So yeah, how do I bring it in? See that right there, but that is not going to display it. Sample code, app code, Earth Engine app. Let's go with this one here. Okay, so I brought in his code. I'm going to hit run. Let's see if this works. Okay, and now I can see, what is this layer? 2021. So I think this is all water surface, rivers, lakes, wetlands, whatever, displayed as raster. Where are we? We are in the Amazon. Okay. Go somewhere closer to home. Yeah, do you see any water? Oh, here's some water. Actually, it's the water from the copper mines. I don't see any water on the Santa Cruz. Yeah, okay. Here we have the Salton Sea. Yeah, cool. What else? Soil properties. Don't know what all this is. Okay, well, I think you guys get the idea. There's two large catalogs that you can just kind of click through, find something of interest, and then they, for the most part, leave sample code of how you can actually bring it in to your Earth Engine environment. So that's powerful in and of itself. There's just tons and tons of data that you can just work with right there. Okay, what else to know? Let's just do some few tutorials here.
Hey, Jeff, is there a search mechanism to search
So
for?
I do a couple tutorials, and these are on Google's official help website. So this is not something that I created. This was contributed by someone in the Earth Engine community. And let's see, this one's called Dynamic World Part 1. Or how about land surface temperature in Uganda? Let's try that one. Okay, so you go through this tutorial. I think it's just, these are really good ideas. Just get like an idea of how do you do analysis in Earth Engine. And it really helps to see lots of examples, tutorials, things that other people have done. You're just trying to start from scratch, like, okay, I want to analyze the land, but yeah, how do I do that? It can be kind of daunting. And so we look what other people did. So what is this one doing? Okay, so we are going to import land surface temperature for 1 year in Uganda. We're going to observe temporal patterns and temperature using a time series chart, and we're going to calculate the mean annual temperature for display and export. Okay. Basically, I would like to have the code so I can do it. And so they provide the code. And so I will copy this code here. Let's just clear this script and start over. Hit run.
There's a question.
What's the question?
Is there a search tool for the data sets?
I think so. I think so. I don't think I've ever used that function. Yes. Yeah, there is. And the Awesome catalog certainly has one. Yeah, they both do. Yeah. How well does it deliver exactly what you're looking for? I'm not sure, but there is search.
What is the best way to search through these catalogs to figure out if they have data that applies for your project?
Right. Seems like both. Seems like you could do keyword searches, but then also just kind of browse through the categories and drill down into what they may or may not have. Okay, so yeah, we were doing this land surface tutorial. I copied some code. I hit run, and looks like, what did it do? All it did was create a polygon of the country of Uganda in Africa. Okay, let's keep going on the tutorial. Okay, now I'm going to input land surface temperature data. So I believe this is from MODIS. Yeah, MODIS is a satellite. Kamal, is MODIS still in operation? Yeah, okay. Still, it's awesome. Okay, I just added some more code, which is going to bring in, I believe, a land surface temperature image. Gonna hit run. Okay, yep, it did it, but it's not displaying yet, so need to do a bit more coding to actually get it to display. Let's try this one. Okay, time series. So in Earth Engine, you can do analysis of imagery and data, but you can also create charts. You can create web apps. So you can do visualizations and stuff that make it a bit more powerful. Let's keep going with their code. I'm not sure where it's going. I've been through this once. Okay, run. Create a chart time series of land surface temperature for Uganda in 2015. Okay. So it created this little chart here. And this chart is land surface temperature, looks like over the course of 1 year, I guess across the entire country of Uganda. And so that data was pulled from the actual imagery. So let's actually display the imagery. Yeah, visualize temperature data on the map. Yes, that's what I would like to do. Okay, so when you're displaying stuff in our little visualizer here, you can actually turn on different layers. And so it has, I believe, the polygon of Uganda, and then it has this mean temperature. I guess the mean temperature is, across an entire year. And I'm not exactly sure, but it's kind of interesting. So just like, yeah, on the fly, we did this. We took MODIS imagery and displayed it as land surface temperature and made a little graphic showing land surface temperature over time for the entire country. So hopefully I give you a little bit of flavor of how this works. So we're not really pointing and clicking. We're not hitting menus. We are using JavaScript code to do so. And then you're probably wondering, how do I know what commands exist in the JavaScript, right? There's a lot of help to help you know what exists and what doesn't. Okay, so over here in our docs, we've got all kinds of kind of help documentation for all the different commands and all the different tools that are available for someone to use. So that's one source of what tools might exist, how to use them. Everything starts with EE dot something, Earth Engine. There's all kinds of raster image analysis stuff or vector image analysis stuff. But honestly, best way I find lately is the invention of the large language model. So how do we know what the JavaScript is to do something you might want to know? Well, I generally would start here at Gemini. So Gemini is Google's large language model chatbot, and it knows Earth Engine pretty well, and it knows JavaScript pretty well. So I can just ask it something. Can you please provide me JavaScript code to create a hillshade for a digital elevation model? I would like to use topographic data that is already in Earth Engine. I should probably preface it with, I am using Google Earth Engine. Okay, here's a JavaScript code snippet to generate a hillshade from a digital elevation model in Earth Engine. So honestly, in 2024, this is probably the way I would start. It starts with like, what do you want to accomplish? What is your goal with your geographic analysis or your imagery analysis? And the first place I would go, honestly, is probably Google's Gemini or ChatGPT to ask it to give me like a rough idea of where I would start. That's typically where I would start. And then I would look through maybe all the tutorials on the Earth Engine help documentation. The last thing I would do is actually look through like the dictionary of tools and how to use them. That to me is like the least useful. I mean, it can be very useful if you're really drilling down, but that is not where I would start. So yeah, so in theory, I could just copy and paste this into my code editor in Earth Engine, and hopefully it would work. That's the beauty of chatbots making code, is that you immediately know if it works or not. There's not really any guessing. Run it. Doesn't work, then that's you get instant feedback if it was successful or not. Okay.
You think Gemini is better for Earth Engine than ChatGPT?
I don't know. I honestly don't know.
ChatGPT for Earth Engine in the past, and it's usually pretty good.
Uh-huh.
If you get into complex stuff, it can be like close to correct.
Yeah, chatbots, I mean, that's the case with everything. Like, it usually gets you close, might not be perfect. So it certainly helps to know a little bit of the JavaScript already, but I don't have an idea. I guess I assume Gemini would be better because it's Google. And because they make Earth Engine and they make Gemini. So I assume they would train their chatbot on their own data, is kind of my assumption. So yeah, that is pretty much when I'm coding anything nowadays. Your chatbots, your large language models are absolutely game changing for making things happen. So it's a pretty exciting time to get into geospatial data science, stuff that requires Python scripting or R scripting or JavaScript, because the large language models are really good at it. And that can really shorten the learning curve for like actually accomplishing things with your geographic analysis. Okay, so that was one little tutorial. Motive, how much time I got? It's 2:32. We'll have a little time to do a tutorial later. Let's just keep going through some of this information if I missed anything. Talked about data catalogs. There's basically two big ones, the official Earth Engine and then the awesome catalog. Okay, Python API. So typically people will use this thing. This is the JavaScript code editor. That is the, kind of the intended place for you to do analysis and run your code, but you can also do it through a Python API. And so if you would like to not use JavaScript and you're more comfortable in the Python ecosystem, that's fine. You can use a Python library specifically meant to touch or contact Earth Engine, and you can do it directly on your local machine, or you can do it in Google Colab or a Jupyter Notebook or any other kind of like Python environment. A lot of people like that because they've done Python for a while and they just kind of like the syntax of it and they're more comfortable doing that. The important thing to remember is if you were interacting with Earth Engine from your local computer to it using the Python API, you are still using Google Cloud's computation ability. And that was the big question I had. I'm like, well, if I bring it to my laptop, aren't I just limited by the laptop? The answer is no. And so it is actually sending the processing request to Earth Engine and using Google Cloud's infrastructure to do it, and then sending you the results back to your laptop. So yeah, so you can work in Python or JavaScript. And if you're interested in the Python API, there's some resources here of exactly how to do that. There's some tutorials on how to get started. There is a huge collection. Someone already put together a bunch of Jupyter notebooks that do a vast amount of things in Earth Engine. So there's tons of resources out there to kind of look at what someone else is doing and try to emulate them. Okay, the next thing we got to talk about is machine learning in Earth Engine. So that's a big question people have, like, do I use Earth Engine as my ML, my machine learning training? And the answer is basically no. And so they have kind of kept that separate. And so the two most common frameworks for machine learning or deep learning is PyTorch, which was invented by Facebook, but it's now kind of open for anyone to use, and TensorFlow, which was created by Google. And so they would prefer you do your deep learning in those frameworks on your local machine or some other computer. And so Earth Engine is not designed as like an engine for ML training. I think you can I think you can do prediction and inference in Earth Engine, but it's got to specifically be using a specific program. I think, yeah, Google has something called Vertex AI. Is that what it's called? Vertex AI. Yeah, Vertex AI. So if you want to build a model and then use it to predict whatever you're trying to do with your AI in Earth Engine, you can, but your model, I think everything has to be hosted on Vertex AI. So you can, but it's more like, here's the few narrow ways they would like you to do it. And yeah, I think you definitely have to like stay within kind of the Google ecosystem. So there's no way to like bring PyTorch into Earth Engine, that kind of thing. I don't think is going to play well together. Yeah, anybody have any questions about that? Did any of that make sense? Yeah.
Bunch of stuff, analyzing.
Okay.
When you're done, you just take that code and save it into like a Jupyter notebook or something, or can you?
What do you do with the code?
Yeah. Like, would you suggest just saving it somewhere?
You can make a duplicate copy. So all of your code does stay here. So there's a tab here called scripts. And so this is like, I can have 100 scripts that all stays right here in my account. So that's where, that's where you're going to keep them as like the first copy, because then you can just pull them up and use them. If you don't trust Google to save them, then yeah, you can export anything you put into Earth Engine, you can take out. And so you can export your scripts, you can export your data products, you can export imagery. I'm not sure what the limitations on that are, but yes, you can get things out of Earth Engine back to your local machine or a server or something like that. Yeah, it all saves, yep, in your script folder, and you can have all the scripts you want. Yes, sir.
Something I've always wondered about the way Earth Engine works, like if you're running something in R, you can run a line and then you pick the next line, but with Earth Engine, it seems like you only run the whole thing all at once.
Yes.
I assume there's a good reason for that, but I'm wondering.
Yeah, no, I've come across the exact same thing. I don't know if there's a workaround. So the question was, can you run, so in our code editor here, can you run it line by line and it remembers the previous line, right? In my experience, no. It seems like you hit run and it just will run everything, and it will run everything again. You know, it's like it'll run on top of whatever you ran previously. There probably is a good reason for that. I don't know. I don't really have a workaround. That appears to be just kind of the behavior of the code editor.
Okay. Once you use the Python API, you can.
Yeah, there you go. There you go. That's probably the workaround. If you use in Python, you could probably control it better just by line. Yeah, and so a great way to access Earth Engine is in a Jupyter notebook. If you're on your local machine doing it, or in Google Colab, that'll talk directly with Earth Engine, and then yeah, you should be able to run it kind of cell by cell. I prefer that way as well. When I was doing the test for this, I'm like, yeah, you have to run it all, which is not always what the developer wants to do. Okay, so we talked about ML, machine learning, and Earth Engine. Earth Engine apps. So in our same code editor, you can have a script of JavaScript that will then create a website around something, your data that you want to share with the world. And I can show you some examples of that. So yeah, back in 2019, I collected a whole lot of drone imagery down at Santa Rita Experimental Range. Stuffed it all into Earth Engine, did a random forest classification on it, identified the different types of vegetation, and it made a little Earth Engine app. So let's click on it. Let's see if it's still alive. I haven't clicked on this in a while. Very suspicious. Oh, no, I clicked on the wrong thing. Example, yes. Okay. Yes, it's still alive. The USDA is still paying for the hosting. Okay, so this is just a little visualization that we made to show drone imagery. So where are we? We're down at Santa Rita Experimental Range, right next to Green Valley. And all of those blue polygons are drone orthomosaic. So it's drone aerial photography. And I can drill down into one of them so you can see what it is. So this is a digital surface model. So it's showing the vegetation heights. And I can go to my layers here and turn things off and on. Let's see. So here's the classification. So if you look on the right here, here's my legend. So it's a classification that is meant to identify herbaceous vegetation, woody, bare ground, or shadows. I can look at just imagery itself. So that's the drone imagery, red, green, blue imagery that I collected at Santa Rita. Yeah, so this is just an example of an app. It's a simple website that you can link, you can send it to anyone in the world, and they can get on here and have an idea of what you're doing. So it's really powerful in terms of visualization and sharing your stuff with people. And this can be done in many different ways. Let's check out a different example here. This is Global Forest Change from Matt Hansen. Link in the tab. So here's an Earth Engine app, and this is globally, it's showing forest change and forest loss. Okay, so I think we have to look at the legend and study it a little bit to figure out exactly what it's telling us. Yeah. This is old. Yeah, this is old.
It says, so click on that right where it says the latest data at, is that another up?
Up.
Right there?
Okay, this site and data are now obsolete. Please see the latest data at. That's going to go to Hansen's website, I think. Let's see what it did. Okay, here's the latest. Thank you. Yeah, I don't know what the colors all mean. Yeah, it's some kind of like forest change, like that amount of forest was lost or that amount of forest was gain. I'm not exactly sure what the data is trying to tell us. Forest loss 2023. Okay, so yeah, it looks like the aquamarine is 2023, red is 2022, so it's going year by year. How's the Amazon going? Yep, I believe some trees are being cut down. Well, you get the point though. So this global forest change analysis was done using Earth Engine, and then they made this nice application or this nice app where anyone can just go to the website and look at the data and visualize it. And so there are probably hundreds and thousands of other examples out there where people are making a little web app, based on their Earth Engine analysis. Okay, it's 2:44. Pretty much covered what I wanted to with it. Could try another little tutorial. Modus NDVI time series. Copy the link. Yeah, so you can do animations. And so you can bring a whole lot of data sets together and then you can animate it into a GIF if you like to do that. But I think I will leave it there. Yeah, so on these tutorials you can click through and yeah, you basically copy and paste the code into your code editor and it should work. And they provide kind of great examples, tutorials on what you possibly could do with your geographic analysis. So yeah, I think I'll just leave it there, give you some of your time back. Guys have any questions? I am not an Earth Engine expert by any means. I've used it for sure, but it's a deep hole and a lot I don't know about it.
Thank you so much.
Yeah, you're welcome.
How do you map drone photos to like geospatial data? What's the mapping? What's the process of mapping? Pre-processing the data.
Okay. Yeah, so drones, typically you would collect just imagery, red, green, blue imagery. And basically you do it through a process called photogrammetry. Something called photogrammetry. So you can take a series of overlapping 2D images to make a three-dimensional map. And the process that we use is called structure from motion photogrammetry. And so there's software specifically out there to do that, like Pix4D or Agisoft Metashape or Open Drone Map. So these are all software programs you can use to take a bunch of drone images to create digital elevation models or orthomosaics or any other kind of like imagery product from drone. Yeah, hit me up, contact me if you would like to learn any more. I know a little bit about that topic. Okay. Any other questions from Zoom? Let's look at the chat. Okay. Thank you, Dan. Yeah, wow. Okay, great. Yeah, it's an older data set, but I still come back to it as kind of an powerful example of what you can do with large processing capabilities. Yeah, please check out the chat. Dan was at Geo for Good conference in 2013, where he saw this global forest change product first presented. And he's saying that the most impactful way to look at it is loss, extent, and gain in that that legend there in that app. So yeah, any other questions in house or on Zoom? Tushar, that's a deep question. He's asking, can I make a career in geographic analysis? What do you think, Kamal? Yeah. Yeah, the answer is yes. I have somehow created a career for myself. Is it working? I'm not sure. I think it is. Yeah, there's definitely job career, career paths doing GIS, remote sensing, geospatial analysis.
What is the likelihood that Google will put the plug on Google Earth Engine as they've done in many of theirs?
Yeah, Kamel's question was, what is Google's business model behind Earth Engine? I've often wondered that because they give it away for free. I think the idea is to capture the scientific community, make it kind of an indispensable tool. We're all using Google. We're all on Google Cloud, and then some of those people will have bigger demands, and then pay for Google Cloud services is probably. But they've been doing it for so long. Earth Engine really came out in like 2015, 2016, something like that. It's a long play, but it's become such a really large user base. A lot of people use it because there's nothing else in the world like it. So
They do organize a workshop actually at the Google Tech up in San Francisco. I think I was interested.
yeah, and I have some colleagues that are way better at Earth Engine than I am. Sam Apriya Roy, a data science colleague up in Alaska Fairbanks, and Erin. She knows way more about Earth Engine than I ever will. Yes, Dan, they do charge large customers for cloud usage. Yes, they do. So they'll give it away for free to the academic community for sure. But if you would need something bigger, you'll have to pay Google a little bit. Okay, so we will leave it at that. Be a little bit of your time. Next week, kind of excited, we're going to get into deep learning. So I'm going to show you guys a Python library called Deep Forest and kind of get you to wade into the world of deep learning, machine learning for aerial imagery. And so this will be for high resolution imagery. I'll be using some of my drone imagery as examples, but we'll step you through it nice and simple. I will have a Jupyter notebook that'll be pre-made and pre-written, to help you guys get started. So that's what we'll do next week. Deep learning for aerial imagery. So see you guys next Tuesday. Thank you.